What if the cosmos itself is a lie detector? Humanity reaches for the stars, yet a brutal truth awaits. The path is paved not with dreams, but with unforgiving material science and the searing demands of re-entry. The easy solutions, the assumed efficiencies, they crumble under immense pressure. We learned this harsh lesson with NASA's Space Shuttle, whose delicate ceramic heat shield tiles, 24,000 individual components, contributed to the catastrophic failure of Columbia in 2003. A fragility exposed. Even today, the struggle continues. Dream Chase's approximately 2,000 larger, silica-based tiles, bonded with silicone adhesives, still face inherent brittleness and thermal stress. Though refined with silicon carbide and advanced tooth-rock material, capable of 1,600 degrees Celsius reusable performance, the fundamental challenge remains. See Aerospace's quest for weeks-long turnarounds, a stark contrast to the shuttle's 4 to 5 months, illustrates a profound evolution in approach. But what if the very foundation of that approach needed to be shattered? A new titan rises, forged in fire and redesigned from its very core. SpaceX's Starship abandoned the $150 per kilogram carbon fiber, utterly unsuitable for 1,600 degrees Celsius re-entry, for $3 per kilogram stainless steel, a material embracing both cryogenic extremes and searing atmospheric friction. This pivot, revolutionary in its simplicity, faced its own brutal crucible. Early FCAW welding created warped prototypes, rough welds, microscopic cracks. The Mk1 blowout during a cryogenic pressure test was a stark, undeniable failure. It demanded a re-evaluation. The solution: 304L stainless steel for enhanced corrosion resistance and cryogenic performance. Upgrades to tip-TIG welding followed, ensuring narrower, deeper penetration and less warping. A custom planishing machine then re-hardened weld joints, smoothing surfaces in a relentless pursuit of perfection against the void. By 2024, the frontier shifted again. Laser welding, initially met with skepticism, proved capable of single-pass, full-penetration welds. This technology increased speed 5 to 6 times over tip-TIG, enabling 20% lighter, thinner stainless steel sheets. Its power concentrated energy into microscopic areas, preventing warping and creating nearly invisible weld beads. The validation was stark. Base stainless steel tore before the laser welds failed. Advanced robotic welding arms from KUKA and Liberty now sculpt long seams with continuous precision, reducing dead weight by approximately 20%. A multi-layered non-destructive inspection regime, utilizing X-rays, ultrasound, and dye penetrance, hunts for hidden flaws. Starbase has transformed into a sophisticated factory, creating incredibly refined, powerful spacecraft. Starship's re-entry system mirrors this material resilience, with durable, flexible hexagonal tiles allowing movement under thermal stress via mechanical mounting and locking fasteners. Beneath, flexible ceramic fiber insulating blankets provide crucial layered redundancy. Its blunt body design and high drag profile push plasma away, spreading thermal loads unlike the concentrated heating of older designs. Yet, even as Starship demonstrates this forged will, the stark failures of Boeing's Starliner program serve as a grim reminder. Persistent thruster malfunctions and helium leaks resulted in a 9-month stranded ISS mission, earning NASA's most severe failure classification. All this from a $4.2 billion contract, compared to SpaceX's $2.6 billion. The cosmos demands not just ambition, but an unyielding, brutally perfected mastery over every atom. If this is the price of entry here, what does that imply for the vast, silent regions beyond?